Next we are discussing some important point. So first point is what? So we can say greatest integer of x is always less than or equal to x and greater than x minus 1. And from here one more thing we can say that this x is always less than greatest integer of x plus 1. Greatest integer of x plus 1. For example, if I say x is 3.7, so greatest integer of x will come what? 3, and greatest integer of x plus 1 will come what? 3 plus 1, 4. So we can say that greatest integer of x is what? 3. That means greatest integer of x is what? Less than 3.7, but 3.7 is what? Less than greatest integer x plus 1, that is 4. So it is less than 4. So this property we can say. And what is x minus 1? 2.7. So we can say that this is x minus 1. So x minus 1 is less than greatest integer of x, and greatest integer of x is less than x, and x is less than greatest integer of x plus 1, we can say. So this is your first point. Second point. What is second point? If I have greatest integer of x plus some m, and m is what? Integer. M is integer. So this m we can take outside. So this one we can have greatest integer of x plus m. For example, if I have 6.7, so this one we can add 6 plus 0.7. So this one we can add what? 6 we can take outside plus greatest integer of 0.7. So greatest integer 0.7 is what? 0. So what will come here? 6. So you can see greatest integer of 6.7 is what? 6 only, and here also we are getting 6 only. If you write this one, we can add like that also. Greatest integer of 5 plus 1.7. So 5 is integer, so we can write is what? 5 plus greatest integer of 1.7. And greatest integer of 1.7 is what? 1. So what will come here? 5 plus 1. Again we are writing 6. So if we have integer, so we can take integer outside. So this is second property. Third property. Third property is what? If I have greatest integer of x plus y. Greatest integer of x plus y. So this is always less than or equal to greatest integer of x plus greatest integer of y plus 1, and always greater than or equal to greatest integer of x plus greatest integer of y. For example, if x is 4.2 and y is 3.7. Okay, so here according to x plus y is what? 4.2 plus 3.7. So what will come here? 7.9. So greatest integer of 7.9 is what? 7. So greatest integer of x plus y is what? 7. And what is greatest integer of x? That is 4. So this one is 4. And what is greatest integer of y? This is 3. So this is what? 4 plus 3 is 7 only. So this is 7 and this is also 7. And this is what? 8 will come. So this is less than this one. Correct? So this is greater than this one, and this is what? Equal to is coming. So this property is there. Now if I take x is 4.2 and y is 3.8. So in this case what will happen? X plus y is what? 4.2 plus 3.8 is what? 8. So greatest integer of x plus y is what? 8 will come. Okay. So greatest integer of x plus y is what? 8 only. So greatest integer of x is what? 4 only. Greatest integer of y is what? 3 only. So here also greatest integer, this is 4, this is 3, and this is 1. So you can say this is what? 8. In this case, in second example, this is 8, this is 8, and this is 7. So in this case, these two are equal, and this one is greater than this one. So this is third property. Fourth property. Fourth property we already discussed. If I have greatest integer of minus x plus greatest integer of x, so this value we discussed already. So this will come 0 if x belongs to integer, and it will come minus 1 if x belongs to not a integer. We already discussed, if not an integer, then minus of greatest integer of x. We can add minus of greatest integer of x minus 1 if x is not a integer. That we discussed. For example, if I take greatest integer of minus 3.7. So this one we can add what? Minus of greatest integer of 3.7 minus 1. So what will come here? This is what? This is directly we can add minus 4, and this is what? Minus of greatest integer of 3.7 is what? 3 minus 1. So this is 4, this is also 4. Minus 4, this is also minus 4. So this is property number 4. What is that? Property number 5. What is property number 5? Y equal to greatest integer of x. Okay, and x belongs to what? Closed interval n to n plus 1. Okay, y equal to greatest integer of x and x belongs to what? N to n plus 1. Okay, where n is what? Integer. Then this value what will come? This value what will come? N will come. Okay, and if I have y equal to greatest integer of gx. Okay, and here if gx is belongs to what? N to n plus 1, where n belongs to what? Integer. N belongs to integer. So y equal to greatest integer of gx value what will come? N only will come. Okay, this is very important to draw the graph of y equal to greatest integer of gx. So if you want to draw graph of y equal to greatest integer of gx, then this property we have to remember. Next property we are discussing, sixth. Okay, graph we will discuss later. Next property is what? Property number 6. According to property number 6, if I want greatest integer of x is less than or equal to m, and m belongs to integer. So here we want x value we want. So how to find out x value? So it is very simple, is that? Okay, so I'm discussing here. First thing we will draw the y equal to, we are assuming greatest integer of x. We will draw a number line. So here we are drawing m. Okay, the next integer is what? M plus 1, and next integer what? M plus 2. Before that what is the integer? M minus 1, and before that m minus 2. So here we want greatest integer of x or less than equal to m we want. Okay, so first thing we have to understood here. Okay, so if I have here x belongs to what? Closed interval m to m plus 1 open. Okay, x belongs to closed interval m to m plus 1. That means this interval m to m plus 1. So what is y equal to greatest integer of x value? So using this property we can say if n to n plus 1, n is integer, then what will come? Y equal to greatest integer x value, n will come. So by using this property we can say that in this interval this one value will come what? Y value what will come? M will come. If I take x belongs to closed interval m plus 1 to m plus 2, then what will come? Y value? M plus 1. Now if I take this interval x belongs to closed interval m minus 1 to m, so here what will come? Y value what will come? M minus 1. Greatest integer x value what will come? M minus 1. If I take x belongs to closed interval m minus 2 to m minus 1 open, so here what will come? Y value what will come? M minus 2. Okay, now by using this one we will discuss this one. So we want greatest integer of x is less than equal to m, that means m, and less than m, that means m minus 1, m minus 2, that we want. So where we are getting m? So here we are getting m, correct? Here we are getting m. So for that interval is coming this one. So we want y equal to m or less than m, that means m minus 1, m minus 2. So all the interval we want. Okay, so you can see when we are getting m in the interval m to m plus 1. Okay, m minus 1 when we are getting m minus 1 to m, m minus 2 where we are getting m minus 2 to m minus 1. So what we will take? We will take union of this one, this one, this one, and previous one we will take. Okay, so we want till m we want. So till we will take value till m plus 1, and before that everything will come, because m minus 1 is also valid, m minus 2 also valid, m minus 3 also valid, and m minus 4 also valid. So we can say that here x belongs to what will come? Minus infinity to maximum value what will come? M plus 1, and m plus 1 is what? Open. M plus 1 is open, because in this interval we are getting m. So this is your answer. Now 7th, if you want greatest integer of x is we want less than m only, less than m, that means we don't want equal to m, that means this will not come. So we want m minus 1, m minus 2, m minus 3, that means till here only it will come. So in this case what will come? X belongs to what will come? Minus infinity to m minus, sorry, m will come. M is what? Open. Minus infinity to m will come. Okay, 8th property, if you want greatest integer of x is greater than equal to m. Okay, m is integer, all the case m is what? Integer. Here also m is what? Integer. So here we want greater than equal to m, That means m plus 1, m plus 2, m plus 3 we want. So here we are getting m, then we are getting m plus 1, then we are getting m plus 2. So m is valid, m plus 1 is valid, m plus 2 is valid, and further also all the things is valid. So till it will go infinite. But what is the minimum value will come? M. So m is starting from y equal to m, we are getting in the interval m to m plus 1. So this interval union this interval union, further interval will come. So this will start from m to m plus 1. Okay, union till infinite it will go. So here we can say x belongs to what will go? Closed interval m to infinite. Okay, ninth, if we want greatest integer of x is only greater than m belongs to integer. That means we don't want m, we want m plus 1, m plus 2. So this is not valid. Okay, m plus 1, m plus 2, m plus 3. So this interval will come minimum interval. So this will come closed interval m plus 1 to infinite. So in this case what will come? X belongs to what will come? Closed interval m plus 1 to infinite. This will come. So these are the property we have to remember.